And now it's time for the Tech Talk. It's the Tech Talk number 5 in the history of 5GZORRO project. And this Tech Talk will explore the new requirements and characteristics introduced by the 5G and 6G networks, which have not previously been covered by previous solutions in the literature, and the current efforts of major standardization groups to homogenize the main process of trust models. The different angles currently considered to provide trust in cross-domain scenarios, as well as some of the current solutions from European projects. We have the privilege, first of all, I need to underline our gratitude to the Universidad Carlos III in Madrid to host this event, and to the technical team. Thank you so much to all of you to give us the opportunity to show and program this event live. Now we have more than 900 people. So it's, for me, it's an amazing number. I don't know what you have in mind, Gregorio, in this sense. So welcome, Gregorio. You are the moderator of this interesting Tech Talk number 5. Trust. Trust is a very amazing word, trust. Even in this moment worldwide, I think. So trust in B5G networks. So I let you to present your distinguished speakers, and great job.
Thank you very much, Andrea. Good afternoon, everyone. Thank you very much for still staying here today live, and also the people watching us in YouTube. Really appreciate it. You know, the big numbers that we are rising here. So this is 5GZORRO. This is final event. Let me recap what 5GZORRO means. This is zero touch, security and trust for ubiquitous computing and connectivity in 5G networks. From there, from the title, based on the words from my colleagues Schweib and Giacomo, and also from the use cases, we have been seeing both the theoretical perspective and also the practical side on the 3 use cases. Now we are zooming in into the word trust. We'll be presenting the view from 5GZORRO. Both my colleague Diego and myself will be providing the standardization view and also how we are seeing things, but also we are quite honored today to be here, to have here two quite distinguished speakers together with us, Tooiba Faisal and Raimo Kantola, first coming from King College London and also working for NetLabs in France, and also Raimo Kantola from Aalto University. So we're going to have 2 different perspectives from people outside, staying here from 2 p.m., seeing what we have been presenting and giving their view, outside view. It is going to help in order to see what other perspective we can have from now on in this trust beyond 5G. The structure that we're going to follow is basically some presentations, 7 to 10 minutes from each of the speakers, starting with Raimo, then Tooiba, Diego, and myself. And then after that, we'll be having a round table. I'm inviting you, people here and people in YouTube, that any presentation, any question coming from those presentations will be more than welcome. We'll be following them, both Andrea and myself, and try to address them as part of this roundtable. This is basically the structure. So this is time for me just to introduce the first distinguished speaker, is Raimo Kantola. So Raimo, let me just put here your slides, and I'm introducing you quickly. This is your stuff. Yeah. So let me introduce you. So one sec, Raimo. Yes. So just giving the introduction for Raimo. Raimo Kantola is Professor Emeritus of Networking Technology at Aalto University in Finland. His research interests have focused on embedding trust into networks, such as 6G, trust solutions, and the digital green transformation. After 15 years of working in the industry in Nokia, he joined Helsinki University and finally has tenure as full professor in 2005. So the floor is yours. Thanks, Raimo.
Thank you, Gregorio, and thank you for inviting me to this distinguished event. Your work has been mainly about the business-to-business relation and trust in business-to-business relation. This is sort of a generalization of the MNO to MNO relation in cellular networks. I take a different view. I'm interested in end-to-end kind of security and how that could be supported in the future cellular networks. Let me see, it's this one. No, it's not this one.
You may use the mouse if you want.
Oh. Yeah. So for end-to-end, it's important to get started with from the bottom. So we have IP, and then in your project, you also assume that IP is the underlying communications medium. However, we know that that is very weak in terms of security. We are sort of, or there's a reason to be afraid that we are building on sand, which is not a good idea. It's better to build on something much firmer. We are talking about ultra-reliable services, but the IP provides just a single path at any given time. Convergence to another path takes a long time, so achieving very high availability performance for end-to-end services is very hard. There's no authentication. We can lie about the address where the packet is coming from, and this leads to very difficult mitigation of DDoS, for example. There are only best of services in the wide area in multi-operator IP networks. Domain names cannot be trusted, and maybe most ridiculous among these weaknesses is this one that BGP paths can be hijacked, which opens the door to man-in-the-middle attacks. Not nice at all. By the way, example of this weakness is my students work on fragment SMAC and segment SMAC. I don't know how well these are known, but basically he found weaknesses both in IP and TCP protocols. And as a result, all the server computers on the internet had to be upgraded. Changes in the operating system had to be made. There is no separation of control plane and data plane. Some kind of answer is SDN, but that has lots of limitations. So in order to go for end-to-end security, it's important to talk about isolation in networks. Sort of security is about isolation. So if the bad guys cannot see you, what you are doing, then you should be more or less secure. Two aspects to isolation is resource isolation, which is weak in IP. We have tried tens and tens of years to do int services, diff services, and neither of them work for the interdomain case because of the weak underlying security. And then there's the security isolation. We can do leased lines, for example, using MPLS. We can create Ethernet circuits, even across multiple domains. But the limitation is that, okay, we could have maybe 2 providers, 3 providers, but there's one customer only. You must sell this VPN or leased line to one customer. And then firewalls, of course, they can, in practice, work with the destination addresses, not the source addresses. Question is whether there's a more generic way to do the isolation for any-to-any services across the network. And if we want to provide end-to-end services, secure services, then this is what we need. The current approach is largely about the subscriber to MNO relation. Your work expand the MNO to MNO roaming relationship to something which is more generic business to business relation, but still the end-to-end is missing. Slicing helps, but on the other hand, this term, in my opinion, is slightly overplayed in the industry, a typical kind of hype term. Then, of course, in security, there's a lot of work on machine learning, like in other aspects of the network, but when it comes to machine learning, we cannot prove anything, right? And also the hackers can use the machine learning, right? The approach that we have been working on is this approach of cooperative security. We motivate that by game theory, prisoner's dilemma, which says that actually the conditions for cooperation over the internet are not in place. The cooperative strategy is not going to be like the sustained strategy that automatically will be chosen. They are hackers, and we know this, right? To counter or mitigate this problem, we suggest that cooperative security would be needed, where two firewalls on the edge of the network can talk to each other and establish a chain of trust from host to firewall to firewall to host. And sort of the firewall becomes an agent of the host as a result. Then the wide area component that we suggest we should look at in beyond 5G and 6G is called SCION, comes from Switzerland, scalability, control, and isolation in networks. This is a working solution. There's working software. We have tested it, quite happy. Couldn't spot any bugs in the software, high quality. This gives massive multipath, and the paths are protected by crypto, so they cannot be faked. Source addresses cannot be faked in this network. They also have a solution for wide area quality of service. So you could reserve resources for end-to-end connection if you want. Also, there's embedded DDoS mitigation. So we implemented a combination of these two. The public service is provided by SCION over the wide area. We run the SCION on virtual machines over FUNET, which is the Finnish NREN network. And then the customer networks were IP-based. Interior routing was IP-based, but the wide area was SCION. So no BGP in use, and then the customer switch, which is our own development, is the default gateway connecting these originator and destinator networks to the wide area. Of course, also alternative kind of scenarios need to be supported at the same time, where the public service would be based on IP. Also, that should be possible, or MPLS. How this then fits with the 5G, 6G, we can put this SCION thing into one wide area slice segment, or many slice segments for different use cases. And then we could run anything sensitive, critical over those slices. Banking, payments. So when you get the bill for 10,000 euro, you don't need to make a call to the sender of the bill, the original sender of the bill, but because the billing company is going to be different, right? So, like your university rules might be, for example, that you cannot click on this, and this is a CEO hoax that is happening here. To eliminate that, we should isolate all these transactions, monetary transactions, from anything else on the internet, right? Also, very natural approach would be to put the core functions, the VNFs that run the core or create the core onto your SCION network, rather than run them over IP, right? Softwareization of networks makes this feasible. Sort of just like 10 years ago, this would not have been feasible at all. But softwareization allows us to do this, right? Surprise, surprise. And the motivation largely comes from the merger of physical worlds and the digital worlds. If we carry on as we are with IP at the bottom, it will mean that hackers will be able to do real world crime, physical world crime by digital means and never get caught, right? Which is very, very expensive for the governments. They need new kinds of police force and not really workable. We shouldn't go there. Okay. Then the cooperative firewalling role is to sort of look at the host level aspects of security and improve the possibilities of deployment of different kinds of things at different paces and make connectivity and the best possible security available to everybody in all cases. Skion has started with the running code approach. There are no specifications yet. They are being created as we speak. And they have the second version this year out, and they have commercial use already. Target, what I see for the industry is that we should be able to sort of containerize the end-to-end service over the internet. It's as safe as a container is safe on a cloud platform to run a service, right? End-to-end. It means sort of virtualization of the end device also at best, but we cannot control that necessarily because it's the big guys who decide about this. So we need other mechanisms to complement the solution if there is no virtualization on the end device. All right, so this gives a new direction or addition that we could, a new challenge that we should take in the 6G community. Right. Okay, thank you.
Thank you very much, Raimo. So time for next presentation. So Tooiba. So time to present Tooiba. Thanks, Raimo, for the presentation. Time to present and introduce the second distinguished speaker, Tooiba Faisal. Tooiba is a research Web3 engineer at Nokia Bell Labs in France. She's recently completed her PhD in telecommunication from King College London. Congratulations, Tooiba.
Thank you.
And has several years of blockchain and smart contracts. She led ETSI standards reports on the topic of smart contract architecture and security. So the floor is yours.
Thank you very much, Gregorio. Okay, my name is Tooiba, as Gregorio said. I will be presenting on the topic of smart contracts. So smart contracts, so all the opinions are my own and Bell Labs, there are no responsibility. Okay, so what are smart contracts? Smart contracts are software codes. They are installed on distributed ledgers and which are immutable data structures. This evening, we have talked about DLT a lot. And everybody, if you search Google Scholar and websites, and everybody's talking about how distributed ledgers can contribute to a trustable environment in an untrustable environment in a trusted manner. Every node keeps a copy of a ledger. That's a reason. That's one of the reasons. Smart contracts particularly are the codes which are installed on those ledgers, and that's how the distributed ledgers becomes dynamic, because distributed ledgers are ledgers. They are static. They don't do anything on their own. Smart contracts actually perform the executions and make them executable and make them dynamic. And since smart contracts are installed on distributed ledgers, they inherit some of the properties of the distributed ledgers. For example, immutable. So they are immutable, like a typical distributed ledger. So they are recorded, they cannot be changed or amended. They're auto-executable. So once we install smart contracts on a ledger, it cannot be changed. It is there forever. So we need to be really careful while we're installing smart contracts in a ledger and when we are doing very serious kind of transactions or using it for a purpose which is very sensitive or even sensitive. And transparent, because similar to distributed ledgers, because they are installed on every single node on the ledger typically, every participant in the ledger keep a same copy of the contract, and they are transparent to the network. Again, typically some blockchains, they actually have like Hyperledger Fabric, they have got channels in which the ledger can be private, smart contract can be private in between two parties, but that's a different topic. So typically they are transparent. These properties are challenging. So it's not simple to use smart contracts and distributed ledgers. I advocate throughout my PhD thesis, and my all research work is on the focus. It's not trivial. It's very difficult. And it has to be managed. These properties needs to be managed in order for us to use smart contracts as a contractual mechanism in future generation of networks or any service provisioning. related to telcos or non-telcos. It needs to be managed. So what we have done to mitigate those problems? So we have worked really hard together with Diego and our HC, ISG, PDL permission distributed ledgers. We proposed a life cycle of a smart contract. So we say that a smart contract should not be installed on a distributed ledger just like that. So it has to go through a series of steps in order for us to mitigate the problems smart contracts they have inherited. And first of all is the template. So stakeholders, they should sit together, they plan a smart contract, and then the smart contract move to the coding phase. And once it's coding, it has to be tested properly. I would ask the interested readers to go through our group report PDL 004, in which we define the detailed process of planning and testing. And we can always go back to the planning phase or the testing phase until it's not stalled. The last step is the development and the deployment and the execution. So smart contract is deployed on the ledger in the third phase as per our life cycle proposed in at CPDL GR004. And even if it's installed and deployed on the ledger, it has to be continuously monitored. So smart contracts should not be left alone or without any monitoring mechanism in order for us to avoid any dangers to the whole contractual system. So we say again, contract moves to the coding phase only when all the stakeholders agree that the smart contract is designed as per the requirements of the system. And so termination, the people who are sitting there with the technological background, they will argue on me in this termination, because smart contract technically cannot be terminated. It's there. It will be running forever as long as the ledger lives. So in the termination phase, we use, again, I will ask the interested readers to go through and look for our report on PDL 004. The termination is the clause actually inside the smart contract and using delays like this. After this time, the smart contract will be inactive. All the variables will be flushed like a typical software program, and the smart contract will be dead. It will be there. It's not deleted from the ledger, but it will be inactive. It will be unusable. So that's the basic report was PDL 004 was a report, and we extend this notion in PDL 0011 as well in this group specifications. So what approaches we have taken in our both the report and the specifications? We focus on access control. The smart contracts should not be deployed by anybody. It has to be deployed, it has to be managed, it has to be called, it has to be executed by the parties which are authorized only. Development life cycle, it has to be the life cycle should be maintained and managed, and it has to be followed. 3-pass approach. So in that we have we have proposed a 3-pass approach in the checklist. So before the deployment, the smart contract has to go through the checklist, like the aviation in the pilots go through the checklist and tick mark everything that we have done, all the checks before it's being deployed. Testing, the comprehensive testing has to be done. It can be in the sandbox, it can be in the production, small production, not the full production, I would say. The small Docker nodes, small nodes, three, 4 systems, they can be connected, and this comprehensive online, offline testing has to be done. Conclusion. So here we will conclude the work. The smart contracts, they indeed provide a mechanism for the successful contractual mechanism. A lot of skepticism we see in industry specifically, that people are not ready to embrace DLT and smart contracts due to the limitations they have and the limitations we talk about. We say that you can do this. It's not impossible, but we need to be ready for it. We need to follow the procedures we have, and we need to be careful when we deploy smart contracts. We need to follow the procedures, we need management, and we need some standardization initiatives. So we all have to agree on the procedures before the deployment of the smart contracts to be followed too, in order for us to use a smart contract. And so yes, we can use smart contracts. Smart contracts is very, very useful tool for us for a future mechanism, as 5GZORRO project is advocating. So on this note, I would conclude my presentation and thank you all for your listening. Thank you very much.
Thank you very much, Tooiba, for your really interesting talk with Raimo. So the third speaker today,
Gregorio, sorry.
Yeah.
Have you said that Tooiba is an amazing career, professional career on their shoulder, because it's a PhD in telecommunication, interest in distributed ledger technologies, service level agreements, King's College at Sea representative. Come on, it's an amazing. It's an amazing efforts in your career. So yeah, congratulations. And even network design for 6G and beyond. So you're looking for 7G or 8G even. Yeah. Congratulations. It's a real privilege to welcome you here. No. It's for us even. So congratulations, Gregorio, and all the people that permit to have this kind of contribution, because
this is true. This is true. So real pleasure, to be here and came to, even he's working for us for 5GZORRO. This is one of the very several projects that Diego Lopez is from Telefonica is having. Yeah. So he will be giving a really interesting talk and view, complementing both 5GZORRO and the experience that he's having.
No, what I've seen, it seems that Diego Lopez is not nobody, but in reality, Diego,
I wish I were nobody, and I was.
Diego Lopez just introducing.
Si quieres te lo digo en castellano.
Just introducing formally, Diego Lopez is senior technology expert in Telefonica. Her Santa Ana started activities to become NFB, for which we are celebrating the 10th anniversary, and currently chairing the ETSI ISG on automations, SSM, and blockchains for PDL that we already mentioned. So Diego, the floor is yours. Thanks.
Thank you. Well, and thank you to all the kind words, etc. I'm flattered, but the proud guy in me really appreciates that. It's something that then
there is humanity in technological development.
No, definitely. That's this is something. Then I will tell my girls if this is going to be on YouTube, right? I'll show them anyway. So when planning the tech talk with Gregorio, the idea was to have two speakers that were from the outside, and I'm trying to bring a little bit something that is connected to what they have been presenting. In fact, I am glad that we were working or talking with people that are working with Skion right now, precisely trying to go for what you mentioned about 6G and using Skion for 6G and things like thinking, though the problem is what you mentioned, that you want to use IP right now is something that sounds like a great heretic statement, and this is something that we have to fight against. And for sure, working with Tooiba has made, I would say, 80% going very high. The 80% of the success of the HCPDL and the attention that has gained is basically is her merit. So it's good to be here. And the idea was precisely to introduce two aspects. Talking about thinking on trust and trust in networking, two aspects that are important for 5GZORRO, or connected to what we have been doing in 5GZORRO. And then another idea that is about the challenge that we have started, that is connected with 5GZORRO as well, because it's something that we are considering for further work. First is about how trust is essential for making anything that you want to automate, especially in an environment like the networking environment, what you have is many different actors, many different stakeholders, consumers, providers, prosumers, because at the end, not any longer there is anyone that is just providing or just consuming. All of us are producing or providing and consuming, and all of us want to get the maximum price for what we provide and the minimum cost for what we are acquiring, things like that. When it comes to precisely supporting automated service provisioning and assurance, what is one of the main goals that we have right now within operators. I would say among our technology providers and our customers, precisely trust is essential, and the way in which you may automate the trust becomes essential as well, which is very much connected to a couple of things that are becoming more and more important. One is the supply chains. Supply chains are becoming longer, more complex, and something that is the pandemics have shown us is that precisely we are extremely dependent of those supply chains. Think about the scarcity of face masks or the scarcity of protection suits at the beginning, of the problems with the different medical supplies, etc. Everybody is interested in this kind of automation, and everybody is interested in having support for trusting whatever is happening. And for sure, both providers, consumers, and take into account that all of us are either at the same time or in most cases providing and consuming. And something that is extremely interesting is precisely that this is very important for everything and for something that at the end is one of the at the core of what we're doing. This is the billing and how you pay and how you are paid for what you provide. Tooiba was mentioning about transparency, and this is something that is equally important if we want to automate in a multi-domain or multi-provider, multi-consumer environment. The capacity of accessing what has happened, to evaluate, to rely on third parties that you trust and not necessarily the other party trusts, but that can help you in finding how to deal with it is something that is essential. And that brings us to everything that has to do with reputation and how you can assess how much trustworthy someone is, depending precisely on the trust that you put in whoever is making this assessment. And at the end is about something that is how we deal with service level agreements, how we can establish, verify, and enforce them. And with this idea of going some steps beyond, and this is why there you have a life cycle, or not a life cycle, it's the basic architecture of smart contracts is how you connect precisely service level agreements with smart contracts, and you make them automatically enforceable, and what is more important even, automatically having a direct automatic economic impact on what you are providing and consuming. The other aspect that we have been looking inside 5GZORRO and is connected with trust is precisely how you use trust, or how you establish trust by verification, how you can rely on the elements that you have there for verifying how much you can trust and how much, or assess the level of security that you can put on a particular service, which is something that as networks are evolving, as we are forgetting precisely about the perimeter security, that I have my firewall, whatever is behind my firewall is secure, whatever is beyond my firewall is unsecure, but while I am behind my firewall, I can be safe. The adversaries right now, well, they have not only cannons, they have tanks, and they have missiles, and they can fire whatever and come over the walls. And something that is important equally as well is that the virtualization breaks all of this. We cannot rely any longer, and that there is a physical barrier that is controlled normally by a big armed guy that is in front of us. It's not allowing you to enter, and you are safe. Your workloads, your data, everything is moving around. You need to have mechanisms to establish dynamically trust and to consume what is referred there as a security self-assessment. The idea is that whatever the entity, using mechanisms that can be trusted, can make an assessment of what is the security state, and that can be dynamically, as we were seeing before when we were talking about the trust and automation, can be evaluated, and a decision can be taken. And that allows us precisely for even a further degree in automation, that is precisely the mechanisms that are autonomous. And even, yes, autonomous, and even, yes, autonomous, because there is this idea that is something that is automatic, have a closed loop that you control. When it's autonomic, in which you are influencing the closed loop with a policy, and when it becomes autonomous and is smart enough to take its own decisions precisely on the different policies that have been communicated. And just to conclude, is about precisely the idea of how to establish a certain level of trust. Oh, well, anyway, what you have is a number of circles of trust between the thing that you can mostly trust in the universe, that is yourself, and going, or at least according to the card, that you can believe that you exist because you're thinking about yourself. But we're not going to talk about philosophy, but if you like, later on we can discuss about that, and how you going further away from your inner point of trust, you can trust more or less, and how you can establish a particular level of trust for a certain service, for a particular environment of a particular goal, which is a new concept that we have started to explore within these discussions on 6G security, because we're trying, or at least some of us are trying to make 6G something that goes a little bit beyond just having a different core that is more agile, or a radio that is faster, trying to go into a different concepts for network architectures and how they interact with the environments. And one of the things that we have is precisely about this idea of that you have mechanisms for establishing which is the level of trust, or how much trust you can put on a particular service when you're asking for it. Something that is very important, is connected to what I was saying before, is precisely that can be evaluated, assessed, and supported by third parties, to which you have trust by whatever the means. It's not that you can trust your government, you can trust your network providers, you can even be crazy and trust Google, for example, or Facebook, but that's up to you. You make your choice, you evaluate your trust. And this idea is precisely we have started to work as a continuation of what we have been doing in 5GZORRO, with the idea of building an environment for assessing this level of trust, using the results of 5GZORRO in a different project that is currently focused on 6G and on the basics of the foundations of 6G architecture. And for sure, we are doing it using or trying to use as much components based on smart behavior and smart contracts and distributed environments as possible. So this is, I believe, at least in this aspect, is a continuation of the project by other means in the future. And with this, I have concluded. So thank you. Well, let's go for the rest of the day.
Thank you very much, Diego. So just last presentation is coming from, let's see where it is. Here it is. From myself. So basically, I'm trying to give some complementary vision based on real things that have been happening in 5GZORRO, real results, but also just trying to transition somehow to what's happening next, which is a roundtable, possibly 10, 15 minutes roundtable, not much time. A set of things that we have been envisioning at the level of 5GZORRO on questions that needs to be solved somehow. My mic. So, I mean, coming here, I mean, this is a picture that both Schweib, Giacomo has been elaborating already. Let me make put the zoom from the trust perspective. So there are 3 steps there. The first one is directly related with how we are discovering things. So the first process on discovery is directly related with the DLT. And we will be hearing on 2 DLTs. One for identifying things, identifying nodes, identifying elements inside the 5GZORRO, and the second one is directly related with where the offers are being published, and on top of that we can start the second step. Second step is directly on the intelligent selection, request, and access. For that, something that Diego was mentioning before, which is reputation. It is basically how humans are behaving. That means, based on our historical information, what we hear from third parties, or some other people, we are evaluating some nodes which is possibly coming into our circle. Something similar is coming into the technology, into the IT, and this is something we're approaching here into 5GZORRO. And the third one is directly related with the trust establishment itself.
So the typical VPN being offered as a service. So coming into the details, you will see 1, 2, and 3 as part of my slides. This is basically helping to identify the 3 main points that I've been commenting before. So the first one, again, DLT, 2 perspectives. First, for the identity, based on governance, and the second one on marketplace. This is basically for the trading of the offers. Second one, based on historical interaction and feedback, we are making something that we call inside 5GZORRO unidirectional trust. So we are providing or giving, let's say, the final customers, the users of those offers, of those services, of those applications, we are giving certain information. So they are not starting like blind. They are having certain information on which of the different offers, meeting their expectation, meeting their intents, is really the best that they can choose. And the third one is the concept of VPNs, but we are evolving that. We have been evolving that as part of this 5GZORRO project in order to create something agnostic to the virtualization technologies being used underlying. So this is why we call it VPN as a service. So my last slide, which is also helping to move, next one, also to move into the roundtable, is basically on the questions that we have been doing ourselves inside this consortium, 3 years work. First thing is how privacy and security foundations might be impacting trust. This is also directly related with Diego, Tooiba, and Raimo. This is something will be coming soon with the roundtable. Which are the new requirements? We have been hearing several times on 6G. Which are the new requirements that we should be considering there? Second question. The third one, everything is supposed to be smart, close to use artificial intelligence. In this particular case of trust, data is quite crucial. Can we establish real artificial intelligence helping to create trust? This is another question that we are doing here as part of the project. Standardization efforts. Do we need to go in this direction? Is there for us where these kind of things are being discussed? Are we creating something like generic information models, generic interfaces that we can, whatever trust model that you're using inside your domain, you can interact and you can use? And the last one is directly related with something that also Diego was mentioning on the virtual function being fully embedded into the network. Can trust be embedded inside the network, inside the services, inside the functions that we are providing, so to increase? So this is the last slide from the perspective of 5GZORRO, and this is, again, guiding somehow what we are going to discuss in this roundtable. So moving here. Moving here and basically opening now the roundtable based on this question that I've been just highlighting and showing. And I would really like to hear from you guys, which is basically the new requirements that you are identifying inside 6G networks. So this is the second of the topics that you are seeing in the slide, but something that I think that might be worth. So we are transitioning between beyond 5G, which is 5GZORRO, and there is also some mentions to 6G. What do you think are the main requirements? So I don't know, Raimo, Tooiba, or Diego?
Of course, there's a lot of inertia in the community developing these technologies. It's like you can take 6G as okay, this will introduce new radio and new devices will be needed and new boxes need to be sold and bought, and everybody should work in the same pace. And but at the same time, I think we should consider seriously the fact that sensing and communication are becoming part of the same platform. So we are reading real world, what is happening there that may be related to humans or devices or some machines. And if something can be hacked in that respect, that sounds pretty dangerous. It means that physical world crime will be made by digital means. So we should do our best in order to avoid this kind of situation with 6G and beyond 5G networks. That has been my argument for going to a leap in level of security in 6G networks compared to what we now have.
Thanks, Raimo. I don't know, Tooiba or Diego, do you want to elaborate a bit more on your perspective?
For From my side, I think standardization efforts is the first point of to initiate the process of starting 6G or moving towards 6G or moving beyond 5G. The reason I'm saying the standardization efforts is that because the technology is evolving, we have got a number of technologies available. We have got AI, we have got machine learning, and every technology, we have distributed ledgers, and every technology, they have got their gaps, and they are not 100% trustable or 100% okay, because when we delegate some of the responsibility to the agents, some of the responsibility to the machines, they make judgments which are close to human, but they can make errors. And who's going to bear the responsibility of that trust, of that action? So I think the standardization efforts can step in and first of all define the scope of the ways the technologies can be used, the areas the technologies can be used, and what technology can, how much we can automate, and how much still we have to monitor until the technology is mature. So if we want to embrace those technologies in 6G and beyond, I think the standardization efforts is the first step towards it. Thank you.
Thanks, Doug. Diego, from your side.
Yes, I would like to make a comment on something that is precisely the pervasiveness of network devices. Not networks necessarily themselves, but the network devices. If you think about how things have evolved from a computer at home that was used by everyone, etc. Well, right now we have in every household, you have several tens of different devices that are connected. And we're moving in the direction in which that will become more and more pervasive. Many of them will not be, it will be unmaintainable. The mechanisms for security that we have right now in terms of patching, antivirus, etc., is going to become unmaintainable because you're not going to care about the security posture of your electric bulb, or it will be very difficult to verify how, I don't know, the thing that you use for positioning your armchair in front of the TV is being controlled. So precisely the idea of how you control the security, how you express your security requirements, how you express your policies, and how they are enforced in a way that are first reaching to this big capillarity of the different services on the one hand, and on the other hand, that is understandable by humans, that is equally important. Is something that I believe is the big challenge. Not to forget the privacy part. That is another thing that is can be extremely delicate.
Thanks, Diego. I will just on top of the word that's the last one that you are mentioning, Diego, the privacy, which is also part of the slides that I was presenting. How do you see the privacy concerns into this huge number of devices and different layers? We are not just speaking about the digital layer, but we are also speaking about the systems and the humans on this 6G world. So there are different planes. Privacy, which is, let's say, a big question mark for 5G and current networks. What about 6G? Seems to be something like really challenging. What do you think?
If I may comment on Lopez very briefly. In Europe, we have a huge shortage of competence in terms of security. It's like security experts are needed more and more and more. And then laymen are responsible for their own security on their homes and so on. And this is not what we want in the future. We want to obtain the same benefits that cloudification and cloud computing give to office computing. So by moving applications to cloud, automation can be taken further. So also for end devices, we can take automation further by applying cloud technology and cloud approach. At least anything that is critical. Then I think we can make progress. In terms of privacy, 6G introduces this idea that sensing is part of the same platform. Even today, we are able to use, for example, Wi-Fi signals to read intimate knowledge about the humans that are within that signal. With 6G radio, we are going to be able to do more in terms of reading what the humans are doing, or how their health is, and so on and so forth. So there will be a huge issue with privacy in 6G. Lots of research work to be done there.
Final comment from your side, Diego or Tooiba. I mean, we are almost closing here. This question.
Just a comment on privacy. Long time ago, when I was younger, I was working precisely on identity federations. Well, let's say my hair had another color. We were working precisely on identity federation and the concerns around privacy. And I remember that there was an expression of a gentleman that was one of the smartest people I have met. It was about your privacy doesn't have any value to me. And this is something that is, the point here is about what we need are the tools so you can do with your data, with your privacy, whatever. But this is something that right now we can't. We simply can't. We are forced to relinquish all of our rights to use certain services. Getting back to this and make this the evolution of the how you express your privacy preferences, and for sure it's in a way that is understandable, that is something that I think is one of the key aspects that we have with whatever the networking and whatever the IT technology that we are thinking about.
Tooiba, a statement, and we are closing here.
Just last comment. I think Diego's point is very valid. The privacy
Open your mic.
is a concern. Oh, sorry. I think I will continue with Diego's point. Privacy is a very crucial point, because privacy actually, when we compromise our privacy, we produce data. When we produce data, we have machine learning algorithms, we have AI algorithms which are trained on that data to do the things which in future. So I think that's a very critical challenge we will face in our future networks and future time which is coming. Thank you very much.
Thank you, Tooiba. It's time for us to close here, because we have a final statement from our coordinator and from one of our board package leader. Thanks, Diego. Thanks, Tooiba. Thanks, Raimo. Thank you very much.